Today, we will learn about estimation and approximation. Usually, we get the count of the objects by counting them one by one. Similarly, in some cases, we get the count by applying some method. The numbers that can be found by counting or by applying some method are called exact numbers. In certain cases, we can't find the exact number. In such cases, we simply do the rough estimation to find the number. For example, number of visiting guests, essential seeds for sowing the field, and sowing time, etc. The rough guess of any number is called estimation. How many marks you will get in the examination is also called estimation. Think about it. You got it right. On thinking, you would have understood that the marks you will get in the examination is also estimation. Similarly, in our daily life, we use round off figures instead of the actual numbers. For example, even though you arrive home at 3 minutes past 9, you will mention it as 9. In case you have to tell somebody if the distance between a city and a village is 2 kilometers and 115 meters, you will mention it as 2 kilometers. The way of expressing a number to its nearest number is called approximation. Can you give some more examples? Think. Let's see how approximation is done. We will understand it by the estimation to nearest tens. Focus on the last digit. If this number is among any number from 1 to 4, let us say 2 in this case, then this number will be closer to 0 than 10. Therefore, estimate the number by writing 0 in its place. If this number is among any number from 6 to 9, let us say 8 in this case, then this number will be closer to 10 than 0. Therefore, we will place 0 in its place and we will increase the value of tens digit by 1. Similarly, if the last digit is 5, as in 15, then the given number is estimated to the next 10. This means placing 0 at once and increasing the values of tens by 1. Today, we have learned estimation and approximation. In the next video, we will learn it better with some more examples. Today, we will see examples of approximation to nearest tens, hundreds, and thousands, and examples of estimating the outcome of number operations. Approximate the following numbers to hundreds and thousands. Focus on the last two digits. While approximating to nearest hundreds, if the number formed by these digits is among any number from 1 to 49, then this number is closer to 0 than 100. Therefore, approximate it by writing 0 in its place. Similarly, focus on the last three digits while approximating to nearest thousands. If the number formed by these digits is among any number from 1 to 499, then write 0 in its place, and if it is among any number from 500 to 999, then write 0 in its place and increase the digit at the thousands place by 1. Next example. Raman wants to buy a gift for his teacher. The gift item cost rupees 215. He has rupees 164. If his father gives him rupees 57, then will it be enough to buy the gift? Find it by estimation. By adding Raman's money with the amount he got from his father, we get rupees 221. If we compare it with the cost of the gift, we can find whether it is enough or not. But this is not required here. Rough estimation saves the time and helps in comparison as well. Therefore, we will find the value nearest to the result. Whenever there is addition or subtraction, let's consider the smallest number. Here, 57 is the smallest number. Then, find the highest place value of that number. The highest place value in 57 is tens. So, we will approximate both the numbers to tens place. The approximation to tens of 164 is 160 and of 57 is 60. Their total is 220, more than 215. Therefore, he will have enough money. Since the outcome is close to the actual result, it is meaningful and accurate. So, can we estimate these numbers to the nearest hundreds and thousands? Think about it. The result won't be accurate with estimation to hundreds and thousands. Next example. Estimate the given value 53 into 287. While estimating multiplication, find the highest value of both the numbers to be multiplied. Here, the highest value in 53 is tens and the highest place value in 287 is hundreds. Then approximate the respective numbers to the highest place. On approximating 53 to tens, we get 50. And on approximating 287 to hundreds, we get 300. Then multiply the approximated numbers, we get 15,000, which is both meaningful and accurate. Today, we have seen examples of approximation to nearest tens, hundreds, and thousands, and examples of estimating the outcome of number operations. In the next video, we will discuss some of the misconceptions related to estimation. Today, we will see some misconceptions related to approximation and estimation. Misconception 1. Approximate 12,748 to the nearest thousands. Many times, there is a misunderstanding that in order to approximate thousands place, it is necessary to have 0 at ones, tens, and hundreds place. This is a misunderstanding. The correct way is that the number formed by the last 3 digits is 748, which is close to 1000. Therefore, it is nullified and thousands place value is increased by 1. Here, another mistake is very common. Sometimes we nullify the last 3 digits but forget to increase the value of thousands place by 1. Similarly, sometimes we add 1 to thousands place but forget to nullify last 3 digits. Misconception 2. Approximate 1487 to the nearest thousands. Sometimes, in order to get the solution, we assume to approximate to nearest tens, then hundreds, and then thousands. This is an incorrect way. The correct way is that if the number formed by the last 3 digits lies between 1 and 499, then it is nullified. This way, the number formed by the last 3 digits of 1487 is 487, which is close to 0. Therefore, by writing 0 at its place, we get the correct answer, 1000. Misconception 3. Approximate 81 to the nearest tens. If the digit in units place is 5 or greater than 5, then while approximating to the nearest tens, the digit to its left is increased by 1. Also, sometimes it is incorrectly assumed that if the number is less than 5, then the digit in tens place should be decreased by 1. This is an incorrect way. Lack of proper understanding of estimation and approximation give rise to such assumptions. The correct method is, if the digit is less than 5, then the digit in units place becomes 0 and there is no change in tens place. Therefore, the correct answer is 80. In this video, we have seen misconceptions related to approximation and estimation.